Okay, we're going to be working on the guided reading for the unit called Gravity and Motion. The learning target is to describe how distance and mass affect gravitational attraction. This will be a pretty quick unit, really only 3 levels to it. And the first level is reading pages 16 to 19, completing the guided reading and correcting it. Make sure you put a mark next to every question, and then add any notes to the class wiki. Again, the learning target, describe how distance and mass affect gravitational attraction. So let's get started on the correct answers for the guided reading. This first part we skip. We always skip these target reading skills. All right, number 1, is the following statement true or false? Forces on Earth are different from those elsewhere in the universe. That's false. And that's really important, that something that Isaac Newton was kind of like the generator of that idea, that the same force that makes the apple fall from the tree is the same force that keeps moons in orbit around Jupiter, for example. And that was a revolutionary idea, but it's really important to science, that the things that happen here on Earth are the same things that happen everywhere in the universe. 2, what is the law of universal gravitation? This law states that every object in the universe attracts every other object. It's kind of a strange idea when you say it that way, but um, gravity is an interesting thing. And a law in science is something that always happens. It's always been proven to happen. It's never been shown to not happen. 3, what 2 factors determine the strength of the force of gravity between 2 objects? The masses of the object is one thing, and the distance between the objects is the other thing. And if you remember our learning target, that's pretty much it. Describe how distance and mass affect gravitational attraction. Those are the 2 factors that determine gravitational attraction, are mass and distance. All right, question number 4. And this all the parts of 4 really hit our learning target. So, the cause and the effect. If mass increases and distance stays the same, then the force of gravity between the 2 objects increases. So if the mass is bigger, then the gravitational force will be bigger. If the mass decreases, so the objects get smaller, but the distance stays the same, then the force of gravity decreases. Okay? If the mass stays the same, but the objects get closer, the distance decreases, then gravitational force increases. And if mass stays the same and distance increases, then gravitational force decreases. E. Use the information in the table to write 1 or 2 sentences about the relationship among mass, distance, and the force of gravity between objects. So this is basically right here is our learning target. So this is what I wrote. If distance stays the same, the force of gravity increases as mass increases and decreases as mass decreases. If mass stays the same, the forces of gravity increases when distance decreases and decreases when distance increases. I think it's best to be thinking of examples of all of these things too. There's a great picture in the book that's pretty helpful. Um, but for me, it's always helpful to think of examples. 5, what is inertia? Inertia is the tendency of a moving object to continue in a straight line, or a stationary object to remain in place. So, in other words, an object in motion will stay in motion, and an object at rest will stay at rest, unless otherwise acted upon by a force. So that's why I'm sitting on my couch here at home. The couch isn't moving, and I'm not moving because of inertia. But if like I roll a ball down the driveway, that ball will roll forever and ever and ever unless some other force stops it. 6, Isaac Newton concluded that 2 factors combined to keep the planets in orbit. The 2 factors were gravity and inertia. 7, circle the letter of each statement that is true about the moon's orbit around the Earth. A, the Earth's gravity pulls the moon toward it, and D, inertia keeps the moon moving ahead. Which is basically that if you throw a football through the air, the inertia keeps it moving ahead, but gravity pulls it downward. And that's why the ball kind of travels in an arc. And if you take that arc that a football travels and pretend that the moon is a giant football that somebody threw, that's why the moon is orbiting the Earth. All right. All right, so make any corrections you need to. Add things to the class wiki, and have a pleasant day.